Welcome to Adventures with a Very Small Lathe. In the last video I ended by drilling 3 holes in the main faceplate, but didn't quite finish these 2 holes. These are vital before the next phase of the project because I defined them as the centre of curvature for the 2 curved slots used to locate the clamps. I'm drilling them to 6mm, way below their final size, as this is a useful diameter to use them to hold the work down onto the rotary table so I can use the table to machine the correct curve. Most of my clamping hardware is 6mm. The drill keeps stalling because I've got it mounted in a collet and it's just a little too small to grip securely. I decided to stop being lazy and switch to a Jacob's chuck. The rotary table has a centre hole machined to a No. 2 Morse taper with a recess at the back, making it straightforward to use a drawbar to hold the faceplate with one of the 6mm holes directly in the centre. It's difficult to use the T-slots to hold the part as there are only 3 of them and they are only at the edge of the table. I prefer a table with the more common design with T-slots across the centre, but right now I don't have one. The part will be very off-centre, so the drawbar is the most obvious option for now. To make the alignment easier, I machined a plastic bushing to sit in the taper and hold the drawbar at the centre of rotation. I used a dial indicator to set the compound to the Morse No. 2 ratio of 20:1, turned the stock down to just under 18mm, turned down the taper, centre drilled to 6mm and parted it off. Some of you may have noticed that I'm using the wrong angle. The 20:1 ratio is the ratio of the length of the difference in diameter. As turning the diameter removes double the measured dimension, I should actually have set the compound to 40:1. The bushing still fits, but it's not as snug as it should be, and I didn't even notice until I was thinking about it later. A custom drawbar was needed, as I needed to make sure it didn't protrude too far at either end. Parallels are obviously required for clearance between the back of the plate and the table, and the length needs to have just enough extra for securing nut and washer on top. The nut at the back of the table needs to fit inside the recess, so the length required to touch that is included in the height of the table. I allowed a generous 7mm for the washer and nut on top, and cut the drawbar from some cheap 6mm mild steel I had kicking around. I turned the ends down slightly to make cutting the threads easier and threaded them with a split die in the tailstock die holder. Everything is now ready to clamp the faceplate to the table, except that the 6mm drawbar doesn't actually fit through the 6mm hole. Back to the lathe. Now I have the part securely clamped, I need to work out exactly where to machine. When I designed this part, I wasn't at all sure what the defining geometry of the curves should be, so I sketched them out roughly in Onshape and started adding constraints. Eventually the geometry was constrained enough to be fully defined, so I can now extract measurements from Onshape to tell me where to machine. I'll use the centre hole as the location reference, and the existing straight slot as the reference for the angles to set the rotary table to. The distance from the horizontal centre line to the bottom of the slot is set 10.7mm, and the distance from the vertical centre line is 17.3mm. Measuring the angles requires some construction lines. The angles of the ends of the curve are 21 degrees and 58 degrees. I used a test indicator mounted in the spindle to align the straight slot with the vertical axis of the cross table and noted the current angle of the rotary table as my centre reference. I then used an edge finder to locate the centre hole of the plate. Not enough travel in that direction, so I'll have to rotate the rotary table all the way around and aligning it to the inverse of the angle I noted down. I'll have to trust the alignment is still good, as I don't have enough travel to re-indicate the straight slot this way round. Now I've found the centre, I can use the handle scales to move to the point on the curve that is vertically aligned with the hole that defines the centre of curvature. From here I can make the cut by rotating the table by the angles I measured in Onshape. A quick check with the calipers to confirm the distances are in the right ballpark. I've locked the cross table, and as I won't need to lock the rotary table, I remove the clamp to give me a clearer view of the scale. I marked the angles with a Sharpie to make it easier to find them, as I know from cutting the previous slot that I'm going to need a lot of passes. The moment of truth. I brought the cutter in for the first pass and fortunately set it so it was only just touching at the centre point. The inner limit of the cut looks basically okay, but the outer point was obviously way too close to the edge and looked like it was likely to break through. What did I do wrong? Checking back to the original schematic, I eventually found two major mistakes. The most obvious is that I measured the vertical distance to the bottom of the slot and then forgot that I needed to subtract the radius of the cutter to get the spindle center point. The second mistake took me longer to track down, but is very similar. A few weeks ago when I located the center holes, I made the same mistake, so those holes are 3mm too far up the plate. This means that the diameter of curvature is significantly larger, so the circumference subtending the defined angle is also much larger. I corrected for the cutter radius but can't move the center holes at this point. I depend on their location to anchor the plate, so I have no choice but to work with the new diameter. I worked out what the new angles should be by measuring them on the table when the cutter was the right distance from the other geometry, and then marked them onto the rotary table scale off camera. As with the straight slot in part 4, it took a lot of passes to complete the feature and took long enough to use up all my workshop time this weekend, so the other slot will have to wait until the next episode. The main challenge will be making sure I can reproduce the same geometry and symmetry. Once I've done that, I'll be bringing the spindle to final dimension, cutting the register in the back of the plate and threading both parts so I can fit them together. Please like and subscribe if you're interested in following this project, and feel free to let me know in the comments if you have any thoughts or suggestions.
you.